All right, on this session, what we're going to do is talk about indoor air quality. As you know, if you look in your book, we've dedicated a whole chapter to this subject material. And the reason being, in the last 2-3 decades, the industrial hygienists, the environmental health and safety people, have had to address indoor air quality concerns. And a lot of this, there's a lot of valid reasons that why it came about. We'll talk about some of those things and what types of problems that we encounter in addressing indoor air quality issues. But basically, those indoor air quality, we started getting complaints about the quality of air inside of a building, and this can be any building, be it an office building where you just have basic offices set up, whether it's a school building, or any building that's occupied. And we started seeing these complaints or hearing about these complaints beginning in the 1980s. And part of the reason for that, for those of you who may or may not be aware, is that the United States was going through an energy crisis back in those times. And so it was very important to try to conserve energy. And so buildings were being built that were tighter than and were more energy conservation oriented. And because of that, because they're being designed that way, we basically built in indoor air quality problems because we didn't have the means to bring in fresh air to replace or reduce some of the low-level contaminants that were being generated in these normal office-occupied buildings. As a result of that, those levels would build up to the point of where it would create a problem. Then, in the last decade, we saw another issue come up, which we're just going to briefly talk about it in this session, but when we talk about biological hazards, we're going to talk much more about it. But that has to do with mold and fungi. And as I said, during the 2000 decade, there became almost a crazy over-concern about mold and fungi in occupied buildings, where people were telling individuals that they had to gut their house because they had mold present inside of it. And so it really did get out of control. And fortunately that it has calmed down somewhat. And certainly excessive mold or fungal growth inside of a building is not good. Doesn't create a healthy environment. But the big key there is excessive. What is excessive? I'm not talking about small little 1-foot spot on a wall. I'm talking about entire ceilings being covered with mold. Well, that is a problem. So in this session, we're not going to go into the mold. We're going to other than briefly talk about it, I'll talk much more extensively about the mold problems in the biological hazards discussion that we'll have in a couple of sessions down the road. So let's take a look at what are some of our typical indoor air quality complaints. So basically, people will start to complain that they're having upper respiratory tract irritation. And that could be from a sore throat, scratchy throat, coughing, sneezing, runny nose, itchy eyes, all of those types of symptomology. And in addition to that, people will sometimes complain of getting headaches or feeling a type of dizziness or nausea, upset stomach, fatigue, inability to concentrate, or just a sense of general discomfort with their work environment. And these are common symptoms. Whenever the environmental health and safety person is called and you start doing an investigation, you will find out these symptoms that I've just described are frequently expressed to you in the course of your investigation, and they are real symptoms and justifiable complaints. If we take a look historically at indoor air quality illnesses, we can pinpoint the causations down to a number of items. And one is a illness that's referred to as humidifier fever. And essentially with humidifier fever, what you're going to develop is flu-like symptoms where, again, you could have fever, chills, nausea, vomiting, typical flu symptoms. Another one is referred to as Pontiac fever, very similar to the humidifier fever, although you won't have any kind of pneumonia-like problems that can occur. Another well-documented illness is caused by the Legionnaire's disease bacteria. Back in the 1980s, in Philadelphia, there was a Legionnaire's convention go on, and a number of individuals that were attending that convention became ill, and many of them died. And when they went in to investigate what was going on, the Center of Disease Control did the investigation, and they found or discovered this organism, this bacteria, which was labeled, had never been before identified, and so the CDC labeled it Legionnaire's disease bacteria. And there was about 6 different genus that was discovered in the course of this investigation. And so LDB is what the abbreviation they use now. Bacteria was found to be a common bacteria that is in all water sources. However, when that bacteria concentration levels get high enough and that water gets aerosolized, like through showers, or in this case at the Legionnaire's disease, it was from the ventilation system cooling towers that were on the roof. There would be a spray that would be emanated from those cooling towers, and it was being drawn into the ventilation system and ultimately distributed throughout the building. And that's how the Legionnaires who contracted the illness contracted that organism. So Legionnaire's disease, still very prevalent. You can go out today in water sources and you can find this organism present. And it's essentially ubiquitous in the environment. It occurs everywhere, and the way you control it is through chlorination of the water system and preventing the water from becoming stagnated to where the organism can build up to high enough levels of concentration that when it does get aerosolized out into the environment would cause illness amongst the building occupants. So Legionnaire's disease, a very real indoor air quality illness. Sinusitis is basically what we're talking about, is when you get a sinus-like reaction. You'll get runny nose, essentially. Asthma, there's many conditions in the indoor environment that will prompt asthma conditions to be exacerbated or worsen. And it doesn't necessarily cause asthma, but it causes those asthmatic symptoms to occur. And then we have another illness that's referred to as hypersensitive pneumonitis. Again, it's a pulmonary function illness. Well, if we look at some of the sources that can cause indoor air quality problems, the first one is very obvious: chemical sources. Many of our businesses will use chemicals even in the in-office environment kind of business, where we're working with copying machines and reproductive machines, and there's various chemicals that are used in cleaning supplies and so on. So we do have chemical potential exposures that occur in any kind of building. Bioaerosols, what we're referring to again is bacteria, mold, fungi, types of problems. At one time, tobacco smoke used to be a real common indoor air quality problem, but now that in most states, tobacco smoke in buildings is prohibited, we've seen a reduction in the number of problems that are associated with smoking going on in any kind of workplace or building structure. And then finally, one of the common problems that we encounter in indoor air quality situation is that of the building has poor ventilation. And so we're not getting proper ventilation to the building. And as a result of that, it creates these low-level contaminants from building up and creating these problems. When we talked a couple of sessions ago about general or local exhaust ventilation, we mentioned that that's one of the culprits that contribute to our indoor air quality problems. Well, let's take a look at what are some of the sources that predominantly occur from outdoors that are brought into the indoor environment that can lead to or create our indoor air quality problem. And some of those chemical substances or sulfur oxides that are produced outside, usually from automobiles or trucks and those kinds of things. Ozone, we could get ozone that's brought in from the outside. Again, ozone's basically just a 3-oxygen molecule. Can be generated from a variety of different processes. Particulates, again, go out and disturb the natural ground area around the building. You generate particulate aerosols that can be captured by the building ventilation system or even brought through windows and doors of the building and enter into the building and create problems. And then a variety of different organic materials that could be, again, being generated outdoors. Some of the air pollutants that are generated indoors are nitrogen oxides, particulates, again, carbon monoxide, organic materials, again, from chemicals that are being used, carbon dioxide. The biggest producers of carbon dioxide inside of buildings are going to be the human occupants. And every time we exhale a certain level of carbon dioxide, which can actually be measured, and it can be a contributor to the poor air quality that we find in buildings. And then mold and fungi and mold spores are, again, can be found indoors from those organisms growing on the building materials. And then those air pollutants or indoor air quality pollutants that are generally generated inside the building are going to be things like, again, chemicals, volatile organic compounds, formaldehyde, your bacteria and fungi. You can get into dust mites, house dust, animals, and dander that animals create. Organic materials, you can get things from contaminants from cooking, ammonia, again, from cleaning compounds. You can get fibers of different types, mineral fibers. And then another indoor pollutant we commonly can find in certain parts of the country are going to be radon, which is a radioactive byproduct of radioactive materials decaying. And radon is one of the daughters that is produced in the decay process. And we typically find this to be a problem whenever we get into buildings that have below grade or below ground surface occupied areas where radon can purge into that area from the soils that are surrounding that subsurface area. Some of the types of activities that can produce our air pollutants are going to be, again, any kind of smoking, which we don't do cigarette smoking much, but if you do any kind of combustion process that creates a smoke, it could be soldering, it could be a welding process, it could be a small burner that's being used. Sometimes people burn candles and things like that. That can certainly generate some air pollutants. Copying machines are a great source of low-level contaminants, chemical substances that are produced. Building materials, if we come in and we install new materials or we come in and we paint building surfaces, then that's certainly a source of chemicals, again, low concentration chemicals, but are being generated in the indoor environment that can create problems to the occupant. Human sources. Humans in our indoor environments are a major contributor to the quality of air that we have. A lot of people will wear deodorants or colognes or perfumes, and then you get people who don't wear any deodorants and stuff and the body odors that they have. So those are all human sources of where various contaminants, and obviously humans are the biggest generator of carbon dioxide from exhaled breath, and those carbon dioxide levels can get to a high enough level where they can create a problem. Carpeting and furnishing, now you see pretty much EPA and many of your indoor air quality experts recommend staying away from any kind of carpeted flooring. You're better off using wood or tile because there's so many contaminants that can be trapped in the base of a carpet that you really can't thoroughly clean those contaminants out of the carpet. And so what happens, your attempting cleaning just regenerates those substances and contaminants back into the airstream that can create a problem. So we try to stay away from carpeting floorings, but also look at furnishings. So what kind of furniture? Again, are the furnishings very porous to where they can contain contaminants and trap those contaminants to where eventually they could be generators of a problem. Any areas where we've got stoves and ovens where cooking can take place, and just food preparation. Whenever we're doing that, whenever I have done indoor air quality inspections and I walk in the front door and all of a sudden I can clearly smell the aroma of coffee, or another good one is popcorn. That's telling me right away that I'm able to pick up those odors so readily that I don't have good ventilation going on in this building. And so I do probably have an indoor air quality problem that needs to be addressed. Again, some other sources, surfacing materials, coatings. These are by painting the walls and putting treatments on the walls. Sometimes you can even do wallpapering. Wallpapering is highly not recommended because depending on the type of material you can use, you can get mold and fungal organisms to grow between the wallpaper and the wall system. So they're growing behind the wallpaper. You can't see them, but yet their spores can be liberated out into the environment that can cause problems. Usually if you see wallpaper, and if you ever see kind of a pinkish sheen to it, that's an effervescence that's being emitted by the fungal organisms that's coming through on that paper, and that's a sign to you that you've got mold growth problems going on behind that surface coating. Floor tile consumer products that are being used, adhesives. We need to look at our HVAC systems, what's being used in them, what kind of air filters are being used, what kind of cleaning compounds are being used in our building, and office products that are being used. So the whole list of types of air pollutants is pretty long. We look at, when we talk about bioaerosols, some of the types of bioaerosols that can contribute to the quality of our air are going to be pollen. Pollen is just that substance that's generated from the flowering process of the plants. If you're in the Phoenix area right now, we've got a lot of pollen that's present, and it's just because it's that time of year. Fungal and mold spores, again, given the right conditions, you can have both of those growing inside a building. If it gets out of control, can create a problem. Bacteria. On bacteria, we can find it from humans. It can be a carrier of it, and it can spread through the buildings that way. Water, as I already mentioned, LDB. Soils and dirts, and if you're into a building structure that pets are allowed, then you can have animal bacterias and viruses. Again, the primary carriers for viruses are going to be your humans and pets. Well, if we look at some of the patterns that are associated, or common patterns associated with indoor air quality, we see clearly that the symptoms are mostly nonspecific. In other words, is that you can't quite pinpoint the same symptom for everybody. One person may tell you they get headaches, another person will tell you they just get irritated eyes and stuff. And so it's very difficult to come up with a very specific diagnosis of the symptomology. We also see that we have forced ventilation is very common in the situation, and many of times what we'll see that the buildings that where the problem exists were built with energy conservation in mind, so we don't have windows and doors that are opened up to allow fresh air, and they have a tendency to build the buildings to minimize the amount of outside fresh air being brought in from an energy factor, and therefore we don't get fresh air diluting down these contaminants that can be present on the indoor air. And because we don't do that, we don't have enough fresh air in there, then these symptoms of indoor air quality will continue to happen until we do take the proper controls. Another problem that we see on indoor air quality is that people get the perception that they have no control over their environment. Oftentimes you'll go into an office space and they will put guards on the thermostats and they're locked, and that's to prevent people from adjusting, because inevitably you get multiple people in an area. Some people are going to think it's hot, some people are going to think it's cold, and some people are going to think it's just right. Well, you get those people who think it's hot or too cold, are going to go over there constantly trying to adjust the environment, and that creates a problem. The other types of things that you'll see people do is maybe they'll have an air supply duct above their desk, and so what they'll do is they'll go tape a piece of cardboard or something over that air supply so that air isn't blowing down on them, and when they do, they throw that ventilation system out of balance. And once it's out of balance, then everything's going to not work properly in accordance with how it was designed, and so it's going to lead to these indoor air quality problems. We oftentimes see indoor air quality complaints when we have high density populations in an area. If you've got 1,000 square foot of space and you only got 1 or 2 people in that space, there's highly less likely to have indoor air quality complaints than if you had 100 people occupying that space. So the density of the number of people is going to be impacted. And oftentimes we see that symptoms that do occur will either occur late in the afternoons or after a weekend break. And in the late in the afternoons, it's because the contaminants that are being generated are building up through the course of the day, and so it's more noticeable in the latter part of the day because the concentrations of the contaminant are higher during those latter part of the day. With respect to after a weekend, is that people get out of the building and space and things clear up, and once they come back into the space on the Mondays is when they start developing the problems again. Well, we do, the industrial hygiene, safety, environmental health and safety people will conduct investigations into indoor air quality complaints and problems. And just some tips about how to conduct those investigations. First, you want to be able to, again, go and listen to the complaints, hear what people have to say, take copious amounts of notes, Ask open-ended questions again. Don't give them a direct question that's either a yes or no answer. Ask them to describe. Meet with your engineering staff who knows the building, how the operating function of the building is, as well as your maintenance staff who takes care of the ventilation system, who changes out the filtering system. And then go physically look, do a visual inspection of the various areas. Look at the mechanical rooms, look at the ventilation system, look at the filters that are being used. You'd be surprised how many times I've done indoor air quality investigations where the engineering or maintenance people say, yeah, we have our system set up to bring in 20% of outside air, and then we walk up there and we find out that the makeup air units have been disconnected and are totally closed. And so you wouldn't know this unless you visually conducted an inspection. In some cases, we do preliminary sampling. Some of the things we sample for is there's an indoor air quality monitoring instrument that will measure for carbon monoxide, carbon dioxide, temperature, and relative humidity. And carbon dioxide is a good indicator to us if we're bringing in enough outside fresh air into our indoor air quality environment. And if we measure carbon dioxide at levels greater than 1,000 parts per million, then that's an indicator to us that probably we're not bringing in enough outside fresh air, and we need to make some adjustments there. But we want to conduct a thorough evaluation of the HVAC system, not only the mechanical system, but also above the ceilings. Many of times I've gone above ceilings and I see supply ducts that are just been disconnected. And so you think you're bringing in air into the space and you're not. Questionnaires, some people like to use questionnaires. I always tell people to be cautious about them. Don't put a lot of weighting in on a questionnaire because they're hard to structure in a way that you don't lead people to answers. And so you have to be real careful there. You can use them, but the value you place on them, be careful. In some cases, you may have to go in and do detailed sampling where you know you've got particular chemicals or think you have a particular chemical of concern. And you may need to go in and do monitoring for it to see what levels that are present there. In some cases, if we have outbreaks of a particular type of illness, it may be appropriate to do medical exams of people and to find out if they're experiencing any adverse medical impact. We always want to review what standards we do have available to us. There are limited in number. We don't have a specific OSHA standard on indoor air quality, nor will we probably ever. But there are some standards that may apply that OSHA has. We need to be familiar with them. And then once we've done our investigation, we want to make sure that we recommend appropriate controls. And it's always a good idea, where possible, is to go back and confirm that the recommendations have been implemented and do some follow-up to whether we have problems or whether we've solved the problem. Again, we don't have a lot of regulations. There are some guidelines out there. OSHA has long proposed indoor air quality standards, but it'll never come to pass. It's too difficult of a regulation to write because there's so much variation and variability from location to location to industry. Industry is just impossible to do. ASHRAE does have some standards. There's the American Standard for Heating, Refrigeration, and Air Conditioning Association. They have published standards for indoor environments. The American Conference of Governmental Industrial Hygienists has developed a biological aerosol bioaerosol book, which is kind of the Bible of how to go out and do any kind of investigations into bioaerosols, which are mold and bacteria and so on. And then we've got, again, some guidelines that you can find on mold in schools and so on. But basically what we want to do is we want to prevent and control our indoor air quality problems from ever occurring. And first off, we want to go and we want to define the nature of the problem that's going on. What are the causes? What are our sources? And then we want to recommend controls and try to implement the most effective, cost-effective control by either reducing or eliminating the substance or materials that are causing it, or by upgrading the ventilation system and the maintenance of the ventilation system, bringing in more outside air, improving the filters and the filtration capacity on the HVAC system. Perhaps increasing or look at the change of when the schedule of when the filters are changed out. Maybe it needs to be increased. As far as some of the things you can do to prevent problems is anytime you have any kind of water intrusion or water problems, flooding, be it from internal sources or exterior sources, you want to make sure you try to get those things cleaned up, dried out as much as possible and as fast as possible. We want to make sure that we look at the pressure balance of a building to make sure that, for example, here that we have a manufacturing process that's taking place in one area of the building and an office area in the other area, is that we don't have the pressure in the operating rooms so high that it causes those contaminants to move into the office space. We want those pressures to be balanced, or if anything, have the pressure in the office area more positive than the operating areas, and have the office air move into the work area space. Whenever we do remodeling, or if we're going to do massive cleaning of the building and so on, try to do those in off hours or on weekends in times where there is minimal occupancy of the building. And whenever we're doing those kind of activities, if we're going to have some construction going on, or we're going to be doing painting or some kind of special thing going on, during those time periods we want to go in and adjust our ventilation system to bring in more outside air so we have more dilution air going on. We want to prohibit air from flowing from a high pressure area to the lower pressure concentration. That way contaminants don't flow from the uncontaminated area into another area. At one time we needed to establish smoking policies. Well, it's usually not the problem anymore. Most locations you have will prevent or do not authorize smoking to be taking place inside of the building, so it's not a problem like at one time it used to be. If we do have mold problems and you find it, go out, get it cleaned up, get it addressed right away so it doesn't become a problem. And then the other thing is to make sure we educate and train the people indoors, our occupants, that we make sure they understand. We do have an honest concern that you as the environmental health and safety people want to look out after their well-being, and that they understand what the problems are and what the potential problems are, and how you're going to go about correcting those things. So to summarize is that indoor air quality problems, they do exist. There is a chapter in your book, as I said, you might want to go through it. But most of the times these problems can be solved. You got to use some common sense, applying all the things we learn in our fundamentals of industrial hygiene approach to indoor air quality problems. Use the same approach that we use to all of our investigative environmental health and safety investigations. Do use the same approach, those common sense approaches in our indoor air quality problems. Make sure that whoever's doing this, if you're hiring somebody to come in and do this work, is that you make sure that people are qualified. There's so many one-week wonders who will go and they'll take a short course, and we saw this in the time where mold got out of control. There's people who would take a one-week class in mold and become experts, and they would come up with all these horrible horror stories associated with mold that scared people to death. And so whoever you do, whatever you do, make sure if it's you doing it that you follow recognized practice procedures. And if you're hiring an outside source, make sure that they are qualified to do the job. So there is a project that goes along with this lecture session, and so it'll be posted here. And you'll want to do it, work on it, and that'll end this session.